Hello students, hello viewers, welcome to Senior College Mathematics. Topic of discussion is algebraic graph. Lesson 8, Quadratic Equations Graph, Part 5. In this part, we are going to consider example 7. So we have example 7, Roman figure I. Copy and complete the following table for the relation y equal to 4 minus s squared. You can see the table of values with some missing values for y. The values of s ranges from minus 4 to plus 4. Roman figure 2, draw the graph of the function using a scale of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 2 units on the y-axis. Roman figure 3, from your graph, find by drawing suitable lines A the values of s for which 4 minus s squared is equal to 2.5. You should use the graph to solve the equation 4 minus s squared equal to 2.5. B part of Roman figure 3. Find the square root of 5.6. Roman figure 4. Using the same axis, draw the graph of 4y equal to 5s plus 4. This is a linear graph. Roman figure 5. Determine the roots of the equation s squared plus 5s over 4 minus 3 equal to 0. So this is the complete problem. Let us provide the solution to it part by part. We have solution, and the first to do is to complete the given table of value and also provide the table of values for the linear function. For the quadratic, we have s equal to 4, y equal to 4 minus s squared. The values of s are already given to you completely from minus 4 to plus 4. To get y, what we need majorly is s squared. 4 is a constant, so you write 4 under each value of s because it is a constant. Then for us to get s squared, you simply square the value of s, each value of s. So you have minus 4 squared is 16, minus 3 squared is 9, minus 2 squared is 4, minus 1 squared is 1, 0 squared equal to 0, 1 squared equal to 1, and so on. When you square the last value of s4, you have 16. In order to get y, you have to subtract 4 and s squared. So 4 minus 16, you have minus 12. 4 minus 9, you have minus 5. 4 minus 4, you have 0. So let's jump to 4 minus 4 again, you have 0. 4 minus 9, you have minus 5. 4 minus 16, you have minus 12. Let us jump to figure 4 first and provide the table of values for the linear function. The function given is 4y equal to 5s plus 4. As you know, y needs to stand alone because it is the dependent variable. So you divide through by 4. If you divide through by 4, you have y equal to 5s over 4 plus 4 over 4. This means y is equal to 5s over 4 plus 1. So we are going to use the same range of values for s as given in Roman figure 1. So we have s values from minus 4 to plus 4. To get the value of y in the linear function, we need 4s over 5. So when s is minus 4, 5s over 4 means 5 times minus 4. That is minus 20. Divide by 4, you have minus 5. When s is minus 3, you have 5 times minus 3. That is minus 15. Divide by 4, you have minus 3.75. If you continue in that order, when s is minus 2, 5s over 4 is minus 2.5. When s is minus 1, you have minus 1.25. When s is 0, you have 0, and so on. 1 is constant all through, so you write 1 under each value of s. Then for us to get y now, you need to add, because the sign here is addition. So you have minus 5 plus 1, you have minus 4. Minus 3.75 plus 1, you have minus 2.75. Minus 2.5 plus 1, you have minus 1.5. This place is minus 3.75 plus 1. That gives that value. When you continue in that order, you have 3.75 plus 1. You have 4.75. And 5 plus 1, you have 6. So we have the two tables of value for the quadratic and linear equation. So we are back to Roman figure 2, where we will construct the graph for the quadratic equation. We start by taking the scale 2 centimeters to 1 unit on the x-axis, 2 centimeters to 2 units on y-axis. If you check the table of values, we have more negative values for y than positive value. So for us to draw the x-axis, we need to look at the values of y. Since we have more negative, you give more space. So you don't just draw the axis anywhere. For example, if you draw the x-axis at the middle of this graph, it cannot accommodate all the negative values of y. So we take it up because the positive are few. So we give more space to the negative value. If you look at the values of s, they are equal. The positive s, they are 4. Negative are also 4. For that reason, you can draw the y-axis at the middle. For you to draw the x-axis, you look at the values of s. For you to draw the y-axis, you look at the value of s. Let me take that again. For you to draw the s-axis, you look at the value of y, and for you to draw the y-axis, you look at the value of s. That will help you to know where to position each of the axes. Okay, back to the scale. 2 cm to 1 unit on s-axis. This graph we are using, each square or box is 10 lines. So that 10 lines implies 2 centimeter. The 10 line box implies 2 centimeters. The 5 line box implies 1 centimeter. So if here is 2 and the scale state that 2 cm is 1 unit on the s-axis, so the first box is 1, the second one is 2, followed by 3, and so on. If you move to the left, you have -1, -2, -3, and so on. For the y-axis, that the same box, you give it 2 units. So from 0 to the end of the first box is 2, the next become 4, then you have 6. When you go down, you have -2, -4, and so on. The next thing is to plot the points. The first point is that when s is -4, y is -12. This is -4 for s, this is -12 for y, and this is the point of intersection. When s is -3, y is -5. When s is -3, -5 is the middle of -4 and -6. That is the point you have here. So you plot this point, a point of intersection. The next point, when s is -2, y is 0. When y is 0 here, s is -2. You plot it directly on the s-axis. When s is -1, y is 0. Y is 3. Y is 3. When this -1, 3 is between 2 and 4. Somewhere here, this is where you have 3, and this is a point of intersection. When s is 0, y is 4. When s is 0 here, y is 4. You plot it directly on the y-axis. When s is 1, y is 3. When s is 1 here, 3 is between 2 and 4. This is the meeting point. When s is 2, y is 0. So when y is 0 here, s is 2. You plot it directly on the s-axis. When s is 3, y is -5. This is a point of intersection. And when s is 4, y is -12. You have plotted all the points. Next thing is to join them together. You must remember that every graph has a title, and the title is the equation or equations you are plotting. Hello. All the points have been joined together. Roman figure 3 from your graph. Find by drawing suitable lines a part of it, the values of s for which 4 minus s squared is equal to 2.5. This is what we plotted. This is the equation whose graph you are seeing. So we have to solve the equation at 2.5. Everything here is equal to y as given in the question. So what it means is that we are to find the value of s when y is 2.5. That is the meaning. So you locate 2.5. 2.5, because from this scale now, one line is 0.2 on the y-axis and 0.1 on the s-axis. So if this is 2, the next line is 2.2. The next line is 2.4. So 2.5 is between 2.4 and 2.6, the middle. So you mark that point as 2.5, then you trace it to the curve, and it's touching the curve at two sides. So one point is here, another point is here. Then you trace it to s-axis. When you trace to s-axis, you have two lines after -1 and two lines after 1, and on the s-axis one line is 0.1. So you have -1.2 and +1.2 is the value of s when y is equal to 2.5, and that becomes the solution to that equation. So then s is equal to plus minus 2.5, 1.2 plus minus 1.2 for s. Then b, square root of 5.6. So you have to adjust 5.6 to look like the equation you have plotted. You can only use the graph you plotted to answer or solve any equation that must be 4 minus s squared on the left hand side. So let's start by letting s equal to the square root of 5.6. For us to get s squared, you have to square both sides. When you square both sides, you have s squared equal to 5.6. We are doing adjustment now. The equation we plotted is 4 minus s squared. To get that minus, multiply through by -1 first. So you have minus s squared equal to -4 minus 5.6. Next, you need to add 4 to both sides. When you add 4 to both sides, you have 4 minus s squared equal to 4 minus 5.6. So therefore, 4 minus s squared is equal to -1.6. So the square root of 5.6 occurs at the point where you have 4 minus s squared equal to -1.6. And what that means is that y is equal to -1.6. It is at this point that you can get the square root of 5.6. So you go to the graph and you locate -1.6, which is somewhere here, because we know that on the y-axis one line is 0.2. So if you keep on adding, you are going to get to -1.6 at that point. You trace it to the curve, and it trace the curve at 2 points. -1.6 touches the curve at 2 points. One point is here, another point is here. You trace both points to the s-axis, noting that one line on the s-axis is 0.1. You're going to have plus minus 2.3 is the square root of 5.6. Hello. Roman figure 4, using the same axis, draw the graph of 4y equal to 5s plus 4. We did the table of value for this relation earlier, and we have y equal to 5s over 4 plus 1. This is the table of values, but we should note that we always use one decimal place because of the nature of the graph. So if we approximate the decimal values to one decimal place, minus 2.75 becomes minus 2.8. That is 1 dp. Minus 0.25 becomes minus 0.3, and the rest values as well. So the first point is when s is minus 4, y is minus 4. You trace minus 4 for s, minus 4 for y. This is the meeting point. When s is minus 3, y is minus 2.8. Minus 2.8 is somewhere here. After 2, the first line minus 2.2, minus 2.4, minus 2.6. So this is minus 2.8. You trace to minus 3, and this is the meeting point. When s is minus 2, y is minus 1.5. When s is minus 2, y is minus 1.5. Then when s is minus 3, I actually skip some values anyway. That is allowed. When s is minus 1, that value is not there. Then when s is 0, y is 1. So when s is 0 here, you have 1 directly on the y-axis. When s is 1, y is 2.3. When s is 1, y is 2.3. That value is kept. When s is 2, y is 3.5. That one is kept also. When s is 3, y is 4.8. Okay, 4.8 is there. 4.8. And when s is 3, and when s is 4, y is 6. So this is 4, and we have 6. This is the point of contact. So we've plotted some of the points, precisely the one that we can locate easily on the graph. So we have to join them together, and you are going to see a straight line graph because it is a linear equation. Alright, so all the points are joined together, and you can see the resulting linear equation. It is a straight line graph. Roman figure 5. Determine the roots of the equation s squared plus 5s over 4 minus 3 equal to 0. You need to adjust or simplify this equation to see if you can get one or both equations that you have plotted. First, the term that contains s squared, that is quadratic, let it be on one side, and the linear term on the other side. So you have s squared equal to, if you transfer plus 5s over 4, it becomes minus 5s over 4. If you transfer minus 3, you have plus 3. For the quadratic graph, we have minus s squared. So multiply through by minus 1. When you do that, you have this. To get the quadratic term, you need to add 4 to both sides. So here you have added 4. And when you do that, you have 4s, you have 4 minus s squared equal to 5s over 4 plus 5 plus 1 plus 1. And you see that the result here shows the two equations that you've plotted, the quadratic and the linear. So the roots of that equation are the points of intersection of the curve and the line. So this one point of intersection of the line and the curve. This is the second point of intersection of the curve and the line. So when you trace to s axis, you have minus 2.4 and 1.2. Minus 2.4 or 1.2. So you always simplify or adjust any equation that is not like the one you plotted. From the whole thing, you understand that if you simplify it, you always get either one or both equations that you have plotted. That is just the simple truth about using the equation or equations you've plotted to solving any other equation. Hello. End of lesson 8. Thanks for watching and learning. Don't forget, watch out for more from the voice of Petakus. Lastly, if you are not safe, your life is in crisis. To avoid that, you give your life to the one that can save you, and that is the Lord Jesus Christ, and you confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Use your hands and your brain to work genuinely and legally, and the Lord will bless you. Goodbye.